Same thing here. 3b squared plus b minus 1 equals 0. Make sure it's equal to 0. Might not be factorable. If it is factorable, it's usually a little bit faster. But this is a way you can do every single problem with the quadratic formula. So in this case, we have a is 3. B, there's nothing in front of that b, so it would be a 1, and c is negative 1. X equals opposite of b plus or minus square root of b squared minus 4ac. All of that is over 2a. So we drop in our stuff here. Let's see, b is 1, a is 3, and c is negative 1. Let's simplify. We have the opposite of 1, negative 1, plus or minus square root of 1 squared, 1 times 1, 1. You're so good. Negative 4 times 3 is negative 12, times negative 1 is positive 12. Ooh. On the bottom, 2 times 3 is 6. Simplify even more. That's square root would add up to 13. Ow. If there were any perfect squares in 13, you would have to simplify them and take them out. Think of this as two separate fractions. This is the same as if I had negative 1/6 plus or minus root 13 over 6. Now, check if you can simplify either part of that. Negative 1/6, nothing you can do. Root 13 over 6, again, nothing you can do. So you don't have to separate them. You can write it like this, but since there's nothing we can simplify, we can just leave it just like this. You can also write it as two separate answers too. You can write negative 1 plus root 13 over 6 and negative 1 minus root 13 over 6, and that works. But you can just write it with 1 plus or minus in between. Kind of saves you a little writing. Just make sure you can't simplify anything out of that still, but you can't here. But I have an example coming up where that might not be the case. Oh.